Alright, so let's talk about integrals of trig and hyperbolic trig functions. Let's see here. So, example 1. Suppose, and it turns out the odd powers are easier, right? So the integral of, let's say, cosine cubed theta d theta. Alright. What I'm going to do is I'm going to trade that for cosine squared theta times cosine theta d theta. Alright. And then that's going to be the integral of 1 minus sine squared theta, right? Because cosine squared plus sine squared theta is 1, all right? And then, of course, I can look at that as what? That's the integral of 1 minus u squared times du. Just let u equal to u equal to sine theta, right? So du is cosine theta d theta, and there you have it. That's u minus 1/3 u cubed plus a constant, and so there's our answer. Sine theta minus 1/3 sine cubed theta plus a constant. Alright, so that's how you integrate cosine cubed. Let's see here. Sort of dual to that, let's look at the integral of, how about, the integral of hyperbolic cinch cubed. I'll use phi for the variable. Alright, so that's the integral of oopsie, cinch squared phi, cinch phi d phi, and let's see here, I give myself a little more room. That's equal to the integral. Now remember, cos squared minus cinch squared is equal to 1. So to change a cinch to a cos, that gives me, let's see here, cos squared minus 1. Cos squared phi minus 1 times cinch phi d phi. Alright, so I'm going to use the sneaky notation here. This is the integral of cos squared phi minus 1 times the differential of cos phi. Because d cos phi is cinch phi d phi, right? So basically I'm thinking of this as my u, right? Anyway, so what you get, 1/3 cos cubed minus cos phi plus a constant, and there you have it. The integral of the cube of hyperbolic cinch is kind of almost the same as, the one we just did for cosine cubed. Now, obviously, I hope you can see, without me working them out, integrals of, sine cubed theta and cos cubed phi are much the same, right? Now, if we do, for example, the integral, and once you get started on this, it's pretty easy to keep going here. Example 2, and let's see here. Suppose I wanted to integrate. I'm going to stick with the hyperbolic one since you guys are probably less familiar with that. Suppose I wanted to integrate the fifth power of cos, so like cos to the fifth x dx, all right? So what you do is you rewrite that as cos squared x, right? Quantity squared, that's cos to the fourth, and then cos x dx. Now, cos squared, right, is equal to 1 plus cinch squared x, right? So this is really the integral of 1 plus Cinch squared x, quantity squared, cosh x dx, right? And then so, if I let u, right, if I let u equal to Cinch x, that means du is cosh x dx. And what does that give us? Well, here, let me move this up just a bit. That gives us, well, this is really the integral of 1 plus u squared squared, quantity squared, times du, right? Also known as the integral of 1 plus 2u squared plus u to the fourth, multiplying that out, right? And so finally I'm going to get u plus 2/3 u cubed plus 1/5 u to the fifth plus a constant, and then finally my answer, which would be hyperbolic sine plus 2/3 Cinch cubed plus 1/5 Cinch to the fifth x plus a constant. Now, I hope you can see that if you can do this, you can just as well do cosine to the fifth, right? Almost the same. There's just like a couple little sine, SIGN differences. And likewise, we could do integral of sine to the fifth theta or sinh to the fifth theta by essentially the same technique, right? In fact, if you start thinking about it, it's pretty obvious that it's just a matter of, you know, well, here, let me show you. Example. Suppose we want to integrate, I don't know, sine the ninth power. Well, I'll write it this way: sine theta, the ninth power of that d theta. All right. So that's really the integral of 1 minus cosine 1 minus cosine squared theta to the fourth power times cosine theta d theta, right? Oh, I'm an idiot. Sine. There's an extra sign here, right? Sorry. Eventually I'll learn. Sine theta d theta. So what I do is I let u equal to cosine theta. That makes it du minus sine theta d theta, right? And I'm faced with the integral of 1 minus u squared to the fourth power times minus du. All right. What is that? Well, let's see here. I think the easiest way for me to do it probably is to use Pascal's triangle. If I'm going to multiply something out to the fourth power, here's what I do. 1, 1, 1, 1, 1, 2, 1, 3, 3, 1, 1, 4, 6, 4, 1, like so. That tells me that if I take the quantity a plus b and raise it to the fourth power, what I get is I get a to the fourth plus 4a cubed b plus 6a squared b squared plus 4a squared b squared. A squared. A, can't do it. I'll learn math eventually. AB cubed, and then plus b to the fourth. All right, so we're applying this binomial theorem in the n equals 4 case to the case that a is equal to 1 and b is equal to minus u squared. Okay, so simply follow that. I'll put the minus out front as to not confuse myself. This minus I'm pulling out front. And then we have integral of what? Well, I'll do it in a different color. Blue. Thinking of something blue. See here. No, orange. Alright, so A is 1. So that's 1. Plus 4 times 1. Well, B is minus. So minus 4u squared. That is this term. Then plus 6a squared. So that basically a you can ignore. So it's plus 6b squared. B squared would be u to the fourth plus 6u to the fourth. All right, 4a, ignore the a, b cubed. B cubed would be minus u squared cubed is what? That's minus u to the sixth power but I have to multiply by 4, so minus 4u to the 6th power, and then finally the b to the 4th term, which is going to give me, let's see here, u minus u squared to the 4th power, just to be clear, that is minus cancels because it's 4th power, and I get u to the 8th. Alright, so plus u to the 8th. du, make myself a little more room over here, so that's equal to minus u plus 4/3 u cubed plus 6 over, or rather minus, can't do math, minus 6/5 u to the 5th, minus gives me plus 4 over 7 u to the 7th, right, minus 1 over 9 u to the 9th plus a constant. Alright, move this down a little bit here, and then finally the answer. Minus cosine theta plus 4/3 cosine cubed theta minus 6/5 cosine to the 5th theta plus, I'll do it down here, 4/7 cosine to the 7th theta minus 1/9 cosine to the 9th theta plus a constant. And there you have it. Now, there's nothing really stopping us from calculating the integral of any odd power of sine, cosine, cos, or sinh. You just do this, and you can use Pascal's triangle to, figure out the coefficients. And, if you got time or your life depends on it or something, you ought to be able to do it. Now, alright, that's all well and good. What about even powers of sine and cosine, right? Even powers. So, example 4. First of all, the integral of sine squared theta d theta. Well, this is going to be the integral. Now here you got to know these half angle formulas, right? This is 1/2 of 1 minus the cosine of 2 theta d theta. I'll start again here in a minute.